Hi guys, welcome back. So in this video, I'm going to show you how to write an equation of a quadratic function in the vertex form when the vertex is provided, and also we also have the other point. So the graph passes through this point 1 and -2, and the vertex is -3 and 6. We did something similar to this where we had already the graph provided to us. And in this case, we do not actually have the graph, we just have the 2 points. But the process is still going to be the same, but I still wanted to show this as a separate example so that people don't get confused that you can only like do it from the graph and you cannot do it when given the points. Guys, graphs are great. If you have a graph, you can just identify the points, and you can also identify the points that are convenient, that are easy to use. For example, if the graph passes through the origin, it's always a great idea to actually use that origin as a point, because 0, 0 is always easy to work with, okay? But in this case, we don't have a graph, we have the points, but the process is still going to be the same. So the first thing first is we want to first write the general vertex form, and then from there we want to see what we have, what is already provided to us, and what needs to be found, and then we'll go from there. Okay, so the vertex form, so solution to this would be the vertex form, which is, we know that is given by y equals to a times x minus h whole square plus k, right? That is my vertex form. But the things that I already know are the h and k. So my h is 3 and my k is 6, right? Those are the coordinates of the vertex. H is the x coordinate and k is the corresponding y coordinate, right? Guys, just by looking at this point, we don't even know whether it opens up or opens down. Based on what we get for A, we can predict, or we can tell whether it opens up or opens down. Okay, so let's start substituting the values. We have y equals to A, and then I have x minus, and then I have a -3 for h, and then square it, and then I have plus 6, right? I just substituted the values for h and k. Let us simplify this further. So what do I have? I get y equals to, I don't have the value for a yet, then I have x, and negative becomes positive, so it's +3, and then square it, and then I still have plus 6. Okay, so far so good. And now from here we know that we have to figure out the value of a. Once we have the a, we are done, right? So to find a, what we can do is we can go back to the other point which is already provided to us and see how we can use that point to calculate a, right? So if I look at this point, it obviously tells me that when x is 1, the corresponding y is -2. So this is the x value and this is my corresponding y value. That is the point where the graph goes through, right? So when y is -2, then let us try to say this is still a here. What is x? X is 1, so it's 1 plus 3 whole square plus 6. And we got to simplify this right hand side and then try to solve for a. It's as simple as that. So I have -2 equals to a, and then simplifying this is 4 square plus 6. Let's take it up here. So I have -2 equals to 4 square is 16, so I can simply say 16a, and then I have a plus 6. Okay, so to get a by itself, the first thing we have to do is subtract 6 from both sides. We get -8 is 16a, right? To get a by itself, divide both sides by 16. When this crosses out, what do I get? I get a equals to -1/2. That already tells me that the graph is going to open down, right? So we'll have this vertex gives us the maximum, right? So we have a. Let's now go back and finally write the equation. So final equation is going to look like, I have already boxed it, so I just have to simply substitute the value for a. Rest, everything is already done. So it is -1/2, and then I have x plus 3 whole square, and then plus 6. This is my final equation in the vertex form. Obviously, if you want to write, like convert it into the standard form, you know, like you just have to first take care of this piece and then multiply by -1/2 and then add 6 at the end. So you know how to do that as well. But here we just want it in the vertex form, so we already got it in the vertex form. Okay. So that also is one other example of writing or modeling a quadratic function. I'm still going to show you some more application problems in the next few videos. and then we'll try to like wrap up this quadratic function unit and then move into probably polynomial functions and higher order functions as well. Okay, so but guys, we really need to know how to solve simple linear equations, system of equations, quadratic equations before we can go into cubic and higher level polynomials. Okay, so guys, take care. I will see you guys in the next video.